Hi, so today we're going to talk about dependency injection with React context. I'm going to start by talking about dependency injection. So when we write React, we write things in components. One of the reasons that we like components is that they provide us with encapsulation. So we have three components here: an alert component, a button component, and the feed component is like a social media feed, so like a list of posts. And these components all have all of their behavior completely encapsulated. So this makes them easy to reason about. We can think about how they work without getting bogged down in irrelevant implementation details. And we can use them anywhere we like inside our application. They're guaranteed to work because they have everything they need encapsulated inside of them. They don't have any external dependencies. So that's pretty great. The downside to completely encapsulating everything like this is that it becomes really difficult to customize our components. And there's lots of reasons that we might want to customize a component. So for instance, with our alert component, we might want to change the color. We might want to make it blue when it's an information alert and red when it's an error alert. And we probably want to change the text so that we can display different messages when different things happen. Similarly, with the button component, we probably want to be able to customize the on-click behavior so we don't have to create a new button component every time we want to click something. And there's even more opportunities for customization with our feed component. We might want to change where we're getting our list of posts from. So for instance, if the user isn't logged in, we might want to show them a curated list of publicly available posts. And if they are logged in, maybe we want to do something really wild and show them a list of posts from people that they subscribe to in reverse chronological order. Could you imagine? We might also want to change the behavior of child components. So again, with our feed component, we might want to say that when the user is logged in, if they click the like button, then we update the state of the post. But if they're not logged in and they click the like button, then we pop a login prompt. We might want to change non-functional requirements, like logging and analytics. This one's particularly important if our component is going to be used as part of a library and could exist in different applications, because the different applications might be using completely different libraries to handle logging and analytics. But even if our component's only being used in a single application, we probably want to send different logging and different analytics depending on where it's being used. And finally, we might also want to replace services for testing. So if our component makes an HTTP request, that's not going to work in a unit test environment. So we need some way to customize that behavior. And if we have all of our behavior completely encapsulated in the component, like in our earlier examples, we can't do any of this. Luckily, there is a solution to this, and that solution is props. We can just externalize any behavior that we want to be able to customize. We can expose it as props, and then we can customize it as much as we like. And that's basically it. That's dependency injection. In his article, Dependency Injection Demystified, James Shaw describes dependency injection as giving an object its instance variables. Now, dependency injection as a concept is something that comes to us from object-oriented programming, which is why he's talking about objects and instance variables. With React these days, we tend not to use objects, but I'm sure he wouldn't mind if we fudge the definition a little to suit our purposes better. And we can say that dependency injection means giving a component its local variables. Now, this might sound to you like we're using a very complicated term for something that's just props. And James agrees with you. He says that it's a $25 term for a 5-cent concept. There is a little more to it than that, though. So first of all, generally speaking, not all props are dependencies. This one is more of like a terminology thing, but for something to be considered a dependency, it usually has to affect something outside of the component. So for instance, with our alert component here, it takes two props, a status prop, which is going to control the color and the icon that we display, and children, which is going to control the text that's displayed in the component. Neither of these things affect anything outside the component. They're just what it is displaying itself. So we wouldn't call either of these dependencies. Similarly, with our button component, it takes three props, The type prop is going to control what it looks like. Children is again going to control what is displayed on the button. And onClick is going to control what happens when you click the button. So all of these things are really just properties of the button, behaviors of the button itself. So they're not dependencies, but the onClick callback might do something like make an API call or update a Redux store or something like that. So it could have a dependency. So they're not, none of these are dependencies, but they might themselves have dependencies. Similarly with our feed component, well, not similarly, I guess, contrastingly with our feed component, all of these props are dependencies. The theme is going to be the same across the entire application. The posts is going to interact with some kind of data store, like an HTTP request, a GraphQL request, or a Redux store, or something like that. OnLike and onComment are going to change which components are being displayed in the application. And analytics service is going to make HTTP requests all over the place. So these are all dependencies. So at this point, you might be thinking, okay, so dependency injection is a name for using fancy props. And that's not quite true either, because not all dependency injection is props. There are other ways to do dependency injection. Remember, it's just anything that lets us pass variables into a component. So for instance, we could do something like this, where we pass the dependencies as a property on the component function object, and then we can access them inside the component just the same as we could with any other property. Doing this, though, kind of raises the question of why? Like, this is a pretty weird thing to do. Why would anybody want to do something like this? Why not just pass it in as props? And the answer to that is mostly prop drilling. So here we can see that the feed component is passed 5 props, and it uses one of them. The other 4, it just kind of passes to its children. And if we have a look at one of its children, like the post component, we can see that it also receives 5 props. And it doesn't use any of them. It passes all of them to its children. So we end up in this situation with even like a fairly simple component tree where we're just passing props in so that we can pass props in, so that we can pass props in. It ends up making our code base quite messy and very difficult to reason about and to trace where things come from. And it breaks encapsulation because suddenly components kind of need to know about the implementation details of their children so that they know which props to pass to them. So we want to try and avoid this. And this passing of properties to the function object is definitely one way we can do that. So you can see here that each component only gets past the dependencies that it actually needs. We don't have to do any prop drilling. Everything just gets like only as much as it needs. There are some downsides to doing things this way though. And the first one is that these dependencies are no longer like controlled in a single place. Like when we were doing the prop drilling thing, we knew that the components were all going to get the same theme because they're all literally getting the same prop passed down. Whereas in this situation, there's nothing ensuring that every component gets the same theme, or the same with any of the other dependencies. There's nothing even in the component to suggest that they should get the same theme. So that's a bit of a downside. And the other downside to doing dependency injection this way is that it's weird. Like, you don't really write React like this. I mean, I guess you used to when we did prop types, but these days, this is not something that you would commonly see in a React code base. So we want to come up with a better solution. So we want something that allows us to manage our dependencies in a single place and allows us to access our dependencies via some kind of Reacty kind of mechanism. And what could be more Reacty than hooks? So that's what we want to aim to use. So with that in mind, the end state that we're going for is going to look something like this. We're going to have some kind of container, which is responsible for managing the dependencies. We're going to pass the dependencies to this container via props. And then inside the child component and the children of the child component and all of the descendants, we can access those dependencies using a hook. Okay, so this is what we're going for. So now we're going to try and actually implement this. The first thing that we need is a function which can return that container component and which can also expose the dependencies which have been passed into the container component so that we can use them in our hook. And that function is going to look something like this. So we've got a single local variable here, which is going to store the value of our dependencies, and then we're going to return this object. And in this object, we're going to return our dependencies variable, and we're also going to return our container component. And the container component is going to take the value of the dependencies as props, and then it's going to update or set the value property of the dependencies variable to those dependencies. And the reason that we need to do this little indirection here using a property rather than just setting the dependencies to the dependencies variable directly is that when we return that dependencies variable inside this object, we want to be able to update it later, right? We need to be able to make sure that the object that gets returned still gets the dependencies updated whenever they change. And then we just return the children. Okay, so once we've got this function, then we can create our hook, which is very simple. It's just going to take one argument, and that argument is the object that's returned from our create dependencies function. And from that object, we're just going to pull out the value of the dependencies and return that. Okay, so I think we're good to go. If we try and use this inside our app, we do something like this. We can create our feed dependencies using our create dependencies function. And then we can use the container component that's returned from our create dependencies function to create our dependencies container. And we can pass whichever dependencies we need into this container here. So for instance, in this component, this is our public feed component. So we're going to pass it. So this is like when the user isn't logged in. So we're going to pass it the list of public posts, and we're going to pass it the functions that let it pop the login modal when we click like or comment. Whereas in our chronological feed component, we're going to pass the list of posts that the user subscribed to, and we're going to give it functions to actually post a comment or post a like. Once we've set up our container, then our components don't care which version of the container they live inside of. They're just going to access the dependencies that they care about via the use dependencies hook. So that's it. We did it. We achieved our goal. We now have a way of managing our dependency using some kind of centralized container, and we can access those dependencies via hooks. The thing is, though, that if we, squint a little bit, maybe change some of the variable names, like instead of calling this create dependencies, we could call it create context. Instead of calling this a container, we could call it a provider. And instead of calling our hook use dependencies, we could call it use context. Yeah, we just invented React Context, which might not be a surprise given the name of the talk. But it turns out that React Context is dependency injection. React Context provides us with a way to pass variables into a component, so it's dependency injection. You've probably been doing it this whole time, whether you like it or not. Sorry. So there are some big advantages to using React Context for dependency injection in a React app. And the biggest one is that it's built in, right? We don't have to learn anything new. We don't have to install a new library. We're not going to increase our bundle size. The thing is going to keep working if we upgrade the version of React that we're using. It's just going to work, and we know how to use it. The downside to using React Context is discoverability. And by that, I mean, it's hard to tell whether a component is using context. There's nothing stopping us from doing this, which is rendering our feed component without rendering the provider around it. This won't cause any errors. React won't complain, and it'll even work up until a certain point. The problem is, though, without knowing exactly what's going on inside the context, we don't know the point at which it's going to break. And even if we do know that, this component could have lots of other child components or descendant components which rely on the same or different contexts. And we don't know the point at which any of those are going to break either. Like in this case, it's going to break when we try and make an HTTP request. But there are different situations where it's going to break in the unit tests that are going to depend on what the context itself is actually doing. And yeah, so we don't know what it's going to break. So now we can't trust our tests, right? We don't know that the reason that they work or don't work is because the code is broken or because the tests aren't testing the correct thing. And the only way we can really solve this is if we go in and like visually inspect every component to try to figure out, like, to see whether it's called use context or not. And we'd have to do it for the entire component tree. And we don't want to do that. So what are our options here? Well, one option is just don't use React context. Like I said, there's lots of different ways to do dependency injection, and there's even a bunch of libraries out there that you can use to help you with this. I had a bit of a look around. I was looking specifically for React-specific libraries. So there are libraries out there that are just kind of generic dependency injection libraries. If that's a thing that you like, go for it. But I'm only going to talk about these React libraries. And to be honest, I could only really find two. And those two are Obsidian and Wox Inject. So let's have a look at how they work. So Obsidian uses annotations to mark dependencies. And the way that it works is that you have to get essentially everything that you import into your application is a dependency, and it needs to be wrapped in a JavaScript class. And then you need to put those classes into this object graph, object graph that's going to figure out what your dependencies are and what's the relationship between the dependencies. Once you've built this graph, then you can inject dependencies into hooks and components. The first thing you need to do is make sure that you destruct your props, because the name of the prop here is going to be what the Obsidian uses to match it against the dependencies. And then you need to wrap your component or your hook inside a call to this inject hook or inject component for a component, which is going to match up the dependencies and the props. It's kind of like a higher order component, but for a hook or a functional component. So the Obsidian docs claim that this approach helps reduce the amount of boilerplate code required by developers, which to me seems like a bold claim for a library that requires that you wrap every single import in a JavaScript class, but that's what they're going with. Generally speaking, though, this absolutely does solve the discovery problem, because we have that graph there. We can see where all our dependencies are, and we know the relationship between them. We're not going to run into a situation where we forget to inject something. It is a little difficult to customize. Like, I couldn't find I could find a way to do it, but I don't like it. The situation where we were passing different dependencies in, depending on whether we were in a public feed or a the user feed. The only way I could find to do it is to do something like this, where we have a different dependency for the public posts and a different dependency for the user posts. And then we have some kind of config that figures out which of those we should be using, which for this particular use case is a bit ick. But if you have a use case where your app has a very static dependency tree, and having that, like, making it statically analyzable is going to be helpful to you, then this library could genuinely be helpful for you, as long as you don't mind writing boilerplate. The other thing about it is that there's no functionality to help you with tests. If you want to mock out things in your dependency graph in a test environment, then you just have to do that by jest mocks. I personally don't like jest mocks, but maybe you do, I guess. So this is definitely an option if that whole situation where it's statically analyzable is going to be helpful to you, then this is a good option for you. Or maybe you just really miss writing Angular and you want more annotations in your code. That could also work, I guess. The other library that I found is called Wox Inject, and I feel like there's some kind of story here, because Obsidian is made by Wix, like Wix, and this library is made by Wox, and neither of those things are words, but they are very similar to each other. So I'll leave it up to your imagination to decide why you think that might have happened. But Wox, just like Obsidian, well, not just like Obsidian, similar to Obsidian, it uses annotations to mark things as injectable, and they need to be JavaScript classes. And then we just use this use resolve hook, which is going to use reflection behind the scenes to match up the dependency with what we want to get passed into the component. So I would call this less boilerplate personally, but unfortunately, this doesn't really solve our problem of discoverability because the dependencies could be anywhere. We don't know what's going to work and what's not going to work in our tests, and they're not that easy to find. It also seems to have the same problem as Obsidian in that it's not very easy to customize components. So if we have our posts component, like if we have our like button component, how do we pass it a different on like handler depending on whether the user's logged in or not? I have no idea. It does include a nice test bed, so you don't have to use mocks. You can just, the test bed will take care of the mocking for you. It's not a whole all batteries included kind of situation. The reflection that it relies on to match the dependencies doesn't work out of the box with TypeScript, so you need to include another library to get that to work, and it also only works with Vite. And generally, to me, this felt like it wasn't quite prod ready. It is currently under active development, so perhaps it will be soon, but this one to me felt like a maybe wait and see. Cool. So obviously I don't actually use either of these libraries, which I guess raises the question, what do I do instead? And the answer to that is I just use context. I find that the way to solve the discoverability problem is just to follow something that I think is generally considered best practice with context anyway, which is when you first initialize your context, don't pass in a default value. Instead, just pass in some kind of non-value. I personally like undefined. You might prefer null. I know some people have very strong feelings about this. I'm not one of them, but I do like undefined because other programming languages don't have it. It feels special. So if we pass undefined as our default context here, and then we render our component without the provider, when we call use context inside the component, it's going to return undefined. So if we add a check in here to check that whether the dependency is undefined, and if it's undefined, we can throw some kind of helpful error message, then we know that we're never going to be in a situation where we're trying to use our component without the correct context having been initialized. This works particularly well if you're using TypeScript because it'll force you to put that check in and you won't just forget. Obviously it's not as nice as some kind of compile time checking would be, but I found that it generally works well enough. Sometimes you've got to run your test a couple of times to figure out all of the providers that are missing, but you get there. It works. It's good enough as far as I can tell. Okay, so that just leaves one last situation where we have dependencies that we need to deal with. That's a situation where we have dependencies that aren't exposed and we want to use them in a test. So the situation I'm talking about is something like this, where we have our login form and it calls this login service. So this login service is affecting things outside of the component. It is a dependency, but it's not exposed anywhere, which means we can't do this, which is a test which we've written to check that the login service is called with the correct arguments. Because we can't get a reference to that login service, like the particular instance that's being used inside the component, then there's no way to write this test. We do have a couple of options to solve this problem. One is that we could expose the login service. We could make it a prop, or we could add it to context, or do whatever. And some people would definitely favor that approach. That's the approach that Obsidian basically mandates. And there's a lot to be said for having all of your dependencies exposed like that. For me, though, it feels a bit like you end up writing code just so that you can make your tests work. And I don't love that. So I personally wouldn't do that, but some people would. Another option is to use jest mocks to mock the function. Like I said, I hate writing jest mocks. I can never remember the syntax, and I always try to declare a variable and then use it inside the mock. And you can't declare variables before you declare a mock because the mocks are like part of the imports and they need to be at the top of the thing, and it never works, and I hate it. So yeah, I don't like doing that either. But if you are a fan of jest mocks, have at it. Problem solved. So given that I don't like either of those options, what do I do? The answer is that I use a library. And that library is React Magnetic DI. So this is another dependency, React-specific dependency injection library, but it's a little bit different to the other couple that I just talked about. Firstly, it's different because I actually use this one. I use it every day at work, and we use it across other parts of the organization for testing products like Jira. The other major difference here is that this library is really only intended to be used in a test environment. So you can use it in your unit tests, you can use it for like storybook stories, you can use it in situations where you need to do something weird in your local dev environment, and you need to inject the dependency to do that. Those are all fine, but you can't use it in production. I mean, you can use it in production, there's a way to force it to work in production, but it's not recommended. Okay, so how do we use this? Well, inside our test, we need to find the thing that we want to find the thing that we want to replace, right? So we've got our that we want to test. So here we've got our login service, and we want to replace it with a function that we have access to, and that we can use in our test. So in this case, a jest mock function. So we're going to call this injectable function, and we're going to pass it 2 arguments. The first thing is going to be the dependency that we want to replace, and the second thing is what we want to replace it with. So we're going to pass in the login service, and we're going to pass in the jest mock function. Then when we render our component, we're going to give it this wrapper, and the wrapper is going to be this DI provider component, which is a React context provider, and we're going to pass it all of the dependencies that we want to replace, so everything that we've wrapped in that call to injectable. And then we can just use our login DI is going to refer to that jest function, and we can use that to test that the service has been called correctly. All right, so it's pretty neat. How does it work under the hood? I'm sure you're asking. Well, at build time, the library goes through and it finds all of the dependencies, and it just does like a string replace and replaces the original call to the dependency with a call to this underscore DI function, and then makes the call to like the return value from underscore DI. Then when our test actually runs, inside the test code, when we call injectable, it's going to add its arguments to a map, right? So login is going to be the key to the map, and jest.function is going to be the value inside the map. Then when the component runs, it's going to call underscore DI, which is going to do a lookup of the map. So it's going to use login as the key, and it's going to get back our jest function. And then that's what's going to get called when we call the actual dependency. All right, so it's pretty neat. It's pretty clever. It's a little teensy bit hacky, which is why it's not recommended to use it in production, but it works really well in a test environment. So this library is doing build time shenanigans, so it does rely on Babel. Or it relies on Babel out of the box. You can actually customize it to use different build systems. You can replace anything that you export, so it's not just restricted to like functions and services. If you have, if you're writing a test that renders a really complicated component tree, and you only care about a small part of that component tree, you could speed your test up by mocking out all of the rest of the component tree using this library. It is best to use it with classes and functions rather than primitive values. It will work with primitive values, but if you replace a value, it's going to replace all instances of that value. So if you, for instance, replace the number 4, then 4 is going to be the key in the lookup table, which means that anywhere that in your code that you have 4, it's going to get replaced by whatever you've put in the map of replace dependencies. So like, if you're replacing a string, it's probably going to be okay because strings are fairly unique across different situations. But like, really don't use it to replace Boolean values because that would be terrible. Generally speaking, it's better just to use it with functions. The best thing about it, though, is that it doesn't require any library-specific code. I mean, obviously, it requires library-specific code in your actual test. But if you have an existing code base, you can start writing tests using this library without making any changes to your actual production code, which is very nifty. Okay, so that was everything that I wanted to cover today. Firstly, we talked about how Dependency injection is a way that we can still maintain customization as well as having encapsulation and avoiding prop drilling. We talked about how anything that passes values into a component is dependency injection. So React Context is dependency injection. We also talked about how React Context has a problem with discoverability, that it's possible to render components without rendering their provider, but we can mitigate that somewhat by always creating our contexts with a non-value for their default value. And finally, we talk about the library React Magnetic DI, which can be super helpful with handling dependencies in tests. If you want to grab these slides, they are up at di.ez.codes. And if you want to get in touch, I am on Blue Sky at ez.codes. Thank you.